Okay, in this third part of the video, the focus will be on how to generate well-log plots. And this is what we're going to generate. Right now, they're all looking identical, but I'm just showing this for illustration. In the lab, you get to work on more realistic cases. So this is what your well-log plots look like. The important thing is that the depth increases going down. So depth is plotted on the y-axis and it increases going down, which is not what you have in your standard plot. In your standard plot, x increases going to the right, y increases going up. But we're going to revert it. And the function we use is called invert axis. And you will see that shortly. So let's move into the code. So this is the code. Let's take this out. These are two ways to load a LAS file, and it's just data the data file format used for well logs. One of the most common is called the LAS file. So it ends with .las. And these are two ways to load the LAS file. You can use the pandas read CSV function, but in this video we're going to focus on this approach, which is numpy's load text function, because this last file is actually just a text file, and this is precisely the one we're going to be looking at. This is what your last file looks like. Version, basically some descriptive information, dates and things like that at the beginning, information about the well, field, it's the vol field, and the data starts from here. So depth is the first column, bulk density is the second column, and you see this minus 999.25 is just a placeholder telling you there was no density data in this interval. But if you keep scrolling down, then you will have non-negative numbers. So the non-negative numbers are actually your bulk density, and bulk density is usually around 2.5, somewhere between 2 and 3 in units of grams per cubic centimeter, gram per cc. So this is the data we're interested in. All these other guys are irrelevant, so we're going to show how to remove this and only extract the data we are interested in. If we go straight to the top, we know these negative values are not part of your data set. Also, this is not part of your data set, so we need to be able to skip these rows and start from here. So we want to skip 48 rows, right, and start from 49. And that's shown here. So this is the file we are opening up. Skip rows 48. So skip 48 rows. Skip the first 48 rows. And all of the data is sitting here. The next thing is we want to grab the DZ, which is the depth, and the bulk density row from the data. We already know first column is the depth, second column is the bulk density, which is what I showed earlier, right? Depth is DZ, row is the density. So we've copied those two into DZ and row respectively. But we already know there's going to be lots of negative 999.25 for all missing data sets. So we want to remove those values. So we use np.where. So np is numpy, right? And we've used this where function before when we're talking about probabilistic distribution. So numpy where the density is greater than 0. The minus 999.25 is less than 0. So true data comes in only when row is greater than 0. So we're going to say where row is greater than 0, grab the Z. So this thing will return true only in those rows where the density is greater than 0. So those are the actual measured data. So this basically cleans your data. It removes all the other data sets where it's less than 0. And you do the same thing, identical stuff within the square bracket, right? You put exactly the same thing within the square bracket, so it removes exactly the same rows from the DZ and from the row. And now you have only useful data in row and DZ. And we can print this investigated depth. Let's run all of this. So investigated depth is between 2,777 feet and 3,738 feet. So that's the interval where the data actually exists. So this is how we generate one well log plot. So let's run it, and you see it gives you just one plot. This is as usual. This is as usual. We specify the color. We want the x-axis to be density. Notice x is density. Y is the z, which is depth. And you specify the labels, how you want it. And this is the important one. Dot invert axis. That is what inverts the direction of the y-axis, so it's not increasing this way, but increasing going down, which is what you have when you go down the subsurface, right? As you go deeper into the subsurface, the depth increases. That gives you your well log. What if we want multiple tracks, right? Multiple well log tracks, like shown here. You use subplots. This is how many columns of well log tracks? 6. So this is 6 tracks, and we show that here. Subplot. So one row, but 6 columns, right? One row of plot and 6 columns. And this is what tells you this is the first track, second well log track, and the last one will be what? 6, right? Because it's going to be 6 columns. So that's how you specify what you're going in each of them. So you will plot exactly what you want. Here we use 2 plot functions, meaning there will be 2 plots, which is why you have 2 plots here. The other ones we use only 1 plot function, so it plots 1. So you can customize the plot as you would with a regular plot. So you see only 1 plot function here. And like I said, the important thing is this. This is what does the trick. And the tracks are specified with the third argument. And you can put different data on the different tracks. And you get to work on this in the lab. That's pretty much it for lab 12. And this is the last material that will be tested on your finals. We will discuss more about this in the Zoom session.